Ken Popkin, and I'm really glad to have your time and attention to present Data 605, the final exam. I am very happy to be at this last step of what's been a very challenging course. This is a very long final, so let's jump right into it. So I chose to do the majority of the exam in Python, as you can see here, using a Jupyter Notebook. Problem 1 was to generate random variable x and y with 10,000 random uniform numbers. So that step was accomplished rather easily. And then from there, I jumped into calculating these 3 probabilities. So as you can see, first one was probability of x greater than x, given that x is greater than y. And I arrived at these 2 values. Moving on to, I'm sorry, here's A. Here's part B, which is the probability of x when you know that y is greater than y. And here's the answer that I arrived at there. Part C was to continue or go back to a given situation, so probability of x less than x, given that x is greater than y. And here's the answer I arrived at for that. Moving on to part 2. I will share this exam took me about 2 weeks, obviously working part-time on it, but I did find it challenging. So investigate whether probability of x greater than x and probability of y greater than y equals, etc. As you can see here by building a table. So we constructed the table. Here's the values that I arrived at, obviously needing everything to accumulate to 1 when you're dealing with probabilities. Taking on the joint probability, you can see I found it to be 37.5%, marginal probability, and I found that the 2 are not equal because the marginal is 50%. Part 3, check to see if independence holds by using Fisher's and chi-square test. My hope going into this was that they would prove to be totally independent since they were each generated randomly and separately, and that did hold up. I got a p-value of 1, so we can retain the null hypothesis and conclude that x and y appear to be independent. Using chi-square had the same result. So again, very confident that we can successfully retain the null hypothesis and conclude that they are independent. Problem 2, it kept getting thicker as I moved into this exam, but I did find the data set extremely interesting and thankfully easy to interpret. So you can see I followed each of the steps here. It's pretty well laid out in the notebook, and I know in the interest of time, I shouldn't dwell too long on any of these. So there's a table of the univariate descriptive statistics using Python's describe command. There's a view of the data frame. And then the histograms took a little bit of playing around, but I got a good figure size on this. And as you can see, got a really nice view of each variable in the data set and the histogram for it. I love that aspect of Python. Scatter plot matrix for at least 2 of the independent variables and a dependent variable. So again, not dwelling too long on this problem, it was fairly straightforward with my beloved Seaborn in Python. And you can see how that shaped up. From there, figured out how to derive a correlation matrix. Is the correlation matrix. You can see you have the ones going down the diagonal. And then I moved into a hypothesis test that the correlations between each pairwise set of variables is 0 and provide an 80% confidence interval. So you can see all of the code that was used to produce that. Let's jump down to the results. So the first pairwise, here's the confidence interval I arrived at. Second pairwise, which is in my case, first floor square footage and lot frontage. You can see I have it labeled for each of the pairwise comparisons. And these are the confidence intervals I arrived at. So what did I conclude from this? Basically, given the features I selected, it does align with my expectations that there is a correlation between all 3 pairs. I did find it interesting that there is a negative correlation between first and second floor square footage. I was anticipating that in general, a home with a larger first floor square footage would tend to positively correlate to have more second floor square footage. And you can see I drew some other conclusions as well. Part 2, linear algebra and correlation. So I performed the inversion using NumPy in the linear algebra library within NumPy, or module within NumPy. I multiplied the correlation matrix by the precision matrix and then did the reverse, multiplying precision by correlation. You can see those results. They are the same. The LU decomposition, pretty straightforward again, using the SciPy library in this case, and just applying the built-in formulas within that. Let's jump over to the R notebook because I had to use the mass package and Python did not have anything near that I could find. So let's look at what we had to do. It was a pretty involved problem, 9 different steps. And fortunately, I did put pretty good comments in here. So select a variable that is skewed to the right. I chose the basement unit square footage. Find the optimal value of lambda for the distribution. See, I'm using lambda to do that. Take 1,000 samples. And when I perform that exercise, I then plotted the histogram. Then created the exponential PDF using the cumulative distribution function. Step 7, getting close to our 9th step, I generated a 95 interval, assuming that we have a normal distribution, and then provided the empirical 5th percentile and 95th percentile of the data. You can see those results right here. And then discussing applying a closed form distribution to the data, for me, did not reveal new information. Given the choice, I would not venture into applying a closed form distribution, as it wasn't, at least in my brief experience with it in this problem, very helpful. Coming back to my Python notebook, we now move into what I found the most interesting part of the exam, and that is to do the modeling. So build some type of multiple regression model and submit your model to the competition board. So took a pretty interesting approach to this. You can see right here, and we'll zoom through it in a second, but I first counted the nulls in each feature to get those removed. If it had over 20% of nulls in any given feature, converted the categorical variables from text to numbers so that I could use those as well in my model. I built a regression model that I use further down here. I run the regression model, and then I go through several iterations using different criteria to try and build the best model possible. So you can see going through the NANDs, that's this data cleanup. Here, converting the categorical variables from text to numbers, I found Python's category codes command to be very helpful, made that extremely simple to move. I didn't go into one-hot encoding because it just felt like extra work in this context of getting through the final given the time constraint. So what did I end up with for a regression model? So first I ran a regression model using all the numeric features, and I know that's definitely going to lead into a situation of but I wanted to get a feel for what this would kick out. And it's interesting, it actually kicked out a pretty good regression model, 82%. And you can see I use k-fold cross-validation so that I'm taking an average of 10-fold. Passing each feature individually now. So what I wanted to do is I knew what it looked like with everything. I wanted to see what it looked like when I built just individual models. And then I assembled all of those into a data frame. And here you see the top 10 independent predictors using only one feature. How good was the model's prediction? It's interesting that overall quality of the home actually gets you to a 63% R squared. Not bad for a single variable. And then the living area and garage, the number of cars that the garage can hold are also significant contributors with the 40%. So from there, I tried to incrementally build a model and was really hoping that that would skyrocket me way above the 80 percentile. That did not happen. As you can see down here, what ended up happening is I ran multi-regression models incrementally. I ended up with a model that actually came out lower at about 78%. So then I went with this model because it used less features. I didn't want to use all of the features. It just seemed like it would lead to overfitting if this was a real world scenario. So I prepared the test data to run the predictions. And I'm going to jump to the end here to show that we started with 83 features and we dropped 5 because of missing data. Then moving through the steps I already covered, we iteratively created an incremental model. And the end result on Kaggle from doing that exercise was that I ended up in position 3,604. So not exactly a Kaggle grandmaster by any stretch, but I do appreciate the opportunity to finally get around to submitting to a competition in Kaggle, because I've done several Kaggle data sets, etc., but I'd never taken the time to learn how to enter a competition. So it was fun to do that while taking the final at the same time. And with that, I'm going to conclude this video. Thank you for listening to it.